Okay, welcome back, and in this video we're going to do more factoring dealing with difference of two squares. One is an application, so part B here is an application, and I'll explain what that application is. But notice this one here, right off the bat it doesn't look like a difference of two squares. So we have to rewrite this to see that it is actually a difference of two squares. And so you might already see this, but let's rewrite it. So I'm going to write this as two squares. So this x to the fourth can be written as x squared squared minus y to the fourth can be written as y squared squared, right? Just using power rule for properties of exponents. And so now it's a difference of two squares where I have my a and my b are the x squared and the y squared respectively. So now I'm just going to do a plus b times a minus b. And so in this case it's just going to be x squared plus y squared times x squared minus y squared. And now look at this. I have another difference of two squares. Now this one, by the way, is not factorable. Do not try to factor this. The sum of two squares is not factorable using real numbers. Okay? So this one we're done with. This is prime. Okay? This one is a difference of two squares. So we can do it again. So now our final answer, we get x squared plus y squared times x plus y times x minus y. And we're done. And so this becomes our product of prime factors. And that's as far as we can go. Okay, now for part B, let me read the setup here, the application. And it says, in analyzing the energy collected by different circular solar cells, the expression 45 capital R squared minus 20 lowercase r squared arises. In factoring this expression, we're going to note a couple of things. Okay, so again, going back to our process. So step one is always see if there's a greatest common factor. So now, in this case, there's a common factor of 5, and it's the greatest common factor. So we're going to factor out a 5, and there's no other factors. We can't factor out any of the r's. So this becomes 5 times the quantity, 9r squared minus 4r squared. And now notice that we have a difference of two squares right here. This is 3r and this is 2r quantity squared. So this means that we can write this as again, just to see it as an intermediate step. Okay? And so now, all we do is use the special product, right? So this just becomes 5 times 3r plus 2r times 3r minus 2r. And we're done. Okay, see you next time.